and so on. So last lesson we saw a few patterns in Pascal's triangle. We talked a little bit about factorials. We might be talking a bit about factorials today too, and to do with this funny formula. Can you remember, like 3 factorial represents 3 times 2 times 1, yeah, 4 factorial, 4 times 3 times 2 times 1, and so on, 5 factorial. How would you represent n factorial? N times, yep, then times n minus 2, times n minus 3, times n minus 4. So because n is the first number, and then notice the second number is just n minus 1, and then the third number is just n minus 2, and so on, n minus 1, n minus 2, n minus 3. So that's how you could write it as a formula, the factorial. Did you have a question?
How do you know, like, when it will stop doing the n minus?
Yeah, you do a little dot, 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 yeah, exactly, that's a good question, yeah. You would have to do a dot, 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 because we don't know when it ends. If n was a massive number, it's going to keep going on for a long time. So we're going to be just finishing off this, because you might have had a lot of questions about the investigation, that's fine. L2, and then we'll start L2. L2 is only about 4 pages, or 2 pages front and back. There are formulas in the formula booklet. So as I said, when we start L2, we'll be focusing on this formula, and just a reminder that you would get this formula in the formula booklet. In the old SL course, you didn't have to do much with this formula, but in the new SL course you guys are doing, then you will have to do some mathematics with this formula. We used to just teach it, but you never had to be examined on it, but now you do. That's why it's in here. Binomial theorem, you kind of like might sort of see a little pattern, like see that thing gets that thing, and so on. First term, you might have noticed a little thing that we were discovering last lesson. Like this, what happens to the powers of A as you go from left to right? Decreases by 1. Yep. So notice n minus 1, n minus 2. What happens to the powers of B?
They increase.
Increase, yeah. So from 1 to 2. What's that say? Oh no, it says R to n. So basically they're just using n and R instead, of course. Okay, so we did a TOK intro. I'm speaking like this because I'm recording so that Chiesa can read over it too. TOK intro, Pascal's triangle, and so on. So we found a few patterns, as you can see, that you guys discovered and could recall. As I said, like at some other point I'll talk about, like, you know, the applications and that kind of thing. We'll just get onto the maths for now. Introduction. So we did a little bit of practicing doing the expansions by hand. So binomial expansion is a method of doing it, a shortcut method, whereas we started off by doing them the long way. A plus b to the power of 1, a plus b squared. If you FOIL it and collect like terms, you get this. So 1, 1, 1, 2, 1, a plus b cubed. When you expand it, you ended up with 1, 3, 3, 1. Then you notice the powers of A were decreasing by 1, the powers of B were increasing by 1. Then A plus B 4 we manually did, quite painful. And then when you did that, you ended up with the numbers, coefficients 1, 4, 6, 4, 1. And you notice the powers of A were descending by 1, powers of B were ascending by 1. And then we started to do the same for 5. We ended up with the coefficients. You guys started to see a pattern. You started to notice that the coefficients were from Pascal's triangle. So for 5, yeah, we did 5 down here. So for 5, the row is 1, 5, 10, 10, 5, 1. And then reading 1, 5, 10, 10, 5, 1. So when it's a binomial expansion and it's an exponent is 5, how many terms do you end up with? Have you noticed? How many terms did we end up with? 6. So just be aware the coefficients you would use are the row that has 6 numbers in it. Because some people get a bit confused, because when you go back to Pascal's triangle, you just have to remember that, for example, it would be this one here. So sometimes people have trouble sort of identifying which row in the triangle they should be looking at, which is why I brought that one up. And if it's to the power of 6, how many terms should there be in the final expansion? 7. Because when it was squared, notice that when there was squared, there were 3 terms in the expansion. When it was cubed, you end up with 4 terms in the final expanded version. When it was to the power of 4, you ended up with 5 terms. When it's to the power of 5, you ended up with 6. And we were kind of in the process of doing this one. I know we've done this one. a plus b to the power of 6, you ended up with 7. And noticing that the terms came, the coefficients 1, 6, 15, 20, 15, 6, 1 came from Pascal's triangle. So that was a painful way to do it by hand. So as you can see, doing it by hand's fine for lower powers. As you get to higher powers, it becomes quite, like, time consuming. So this is a nice shortcut method for doing it. Picked up on a pattern, a plus b cubed. You notice what can be said about the powers of a and b. You notice from left to right, the powers of a are decreasing by 1, and the powers of b are increasing by 1. By a and b, we mean the two terms in here. Write down the triangle coefficients to row 6, so you guys realize it was Pascal's triangle. You're also asked to investigate the predictability of each row from the previous one. So this was just assuming you didn't even know what Pascal's triangle was about, so it was just that you add 2 numbers above it. So you add the 2 numbers above to get the number below. Add the 2 numbers above to get the numbers below. And the last one was find a formula for finding the sum on the nth row. So the sums were, according to this version of the triangle, the sums were 2, 4, 8, 16, 32, 64. And so 2 is the same as 2 to the 1, 4 is the same as 2 squared, 8 is 2 cubed, 16 is 2 to the 4, and so on. So therefore, in this case, they're calling this row, row 1. So they're not calling the one at the top row 1, they're calling 1, 1, row 1. And then so 2 to the power of n makes sense. And we're up to here. Use the results from 5 to predict the elements of the 7th row of Pascal's triangle. Hence, write down the binomial expansion of a plus b to the power of 7. So what are the numbers in the 7th row of Pascal's triangle? I'll write down.
1, 7, 21, 35, 35, 21, 7.
Yeah, you notice it kind of is symmetrical as well. We'll pick up on that. So of course the first term will be 1, a to the power of 7, because it's all to do with a plus b. So what would be the coefficient of the second term? 7, yeah. So plus 7. And what will be the power on a? A 6, yeah, and b. Like that. Second term, we can just say what would be the whole third term, sorry.
35,
Yeah. The next one, we'll see pattern 8. Yeah. And the next one. Yeah. You have to really concentrate, don't you? And then continuing on.
21,
Yeah.
7,
Yeah, that's right. You don't need to write 1d7. If it helps, you could put in the 1. So that's pretty long. This one was easy enough because when you've just got single terms like a and b, it's kind of easy enough. But what if you've got like numbers in there? Like what if you've got 2 plus b, or 3 plus x, or 4 minus x? In that case, if you had 4 instead of a, you would have to work out what is 4 to the power of 6, and then times it by 7. You would have to sub in. So instead of a, you would sub in the number. So if you had something like 3 plus 2x, a bit complicated then, you would have to replace all the a's with the number 3 and all the b's with the term 2x, and you might then need to work out what those values are. So that's what we'll be doing kind of in 2 pages ahead. Yeah, that's just confusing. For now it's kind of nice and easy. Let's just practice finding numbers on the calculator. Things called, you're going to be using special buttons. I don't think your calculators have these buttons as far as I know. But yeah, so we can use a scientific calculator to find that, but we're going to be using our versions are the TI-84 Plus. So I've kind of added something extra in here. On your versions of the TI-84 Plus, if you haven't discovered it already, you might find another way to get there too, because remember on your calculators there's often multiple ways to get to these particular values. Let's open up the calculator. So one way is to go to here. So on your versions, you would press math, and then you can go across to probability. Then there's a thing called NCR. We don't seem to have that key. We seem to have NCR. And then manually enter in 8 and 2. They want us to work out NCR when N is 8 and R is 2. That's because that's what the questions here is asking us to do. So I'll do a little demo of it too on here. So if you go on math, then I would go across to probability. There might be other ways to get there too, as I said. If you find alternative ways to get to NCR, feel free to use them instead. Don't use NPR. This one is about NCR. C for combinations, kind of. How many, kind of what Grace was talking about, combinations. NCR, and then you would open it up. And the great thing is, it kind of allows you to put in the numbers here. They want us to work out, they want us to put in N is 8, according to this one. N is 8, and R is 2, according to this question. So we just plug in 8 there, and we arrow across to 2 here, and enter. 28. So it's just confirming that we know what to do. So you might want to write down those instructions. It already told us that the answer is 28, but I thought let's just write it in as well. The answer is 28. So what it's asking you to do now is use your calculator, find out versions of these. If you want to rewrite them, the way we would rewrite them, we could go 4C0. That's the way our calculator kind of writes it. They should be both sort of like subscript, so I'll try to make it a bit more like subscript. 4C0 equals. And then we're going to work out what 4C, no, not 4C. Yep, 4C1 equals. We're going to work out what 4C2 equals. 4C3 equals. So just have some of you might have done it already. So just have a little plug and try working out those answers if you haven't already. Have you done them all already? Are you that fast? Okay, you found them, good. Okay, so what did 4C4 equal? What? Yep. Oh, sorry, 4C0. Yep. 4C1. 6. Yep. So it might be helpful to sort of write those out like this. 1, 4, 6, 4, 1. Just to do my sort of see a little pattern there. 1, 4, 6, 4, 1. Interesting. So therefore, what do you think, doing these calculations, what do you think this little weird calculation is working out for you? Yeah, it's working out rows, values in Pascal's triangle for you. That's what it's doing. So it's saying, okay, fourth row, the first term they call 4C0, second term they call 4C1, 4C2, 4C3. So that's the thing you've just got to keep in mind. The first term they'll call 4C0. That gets you 1. We're also in lesson 2 we learn out we learn the formula. You know that funny formula with all the factorials? That formula is what the calculator's doing. So that funny factorial formula actually manually calculates this. So the calculator's doing that for you when it does that. It's working out n factorial over r factorial, n minus r factorial. So in lesson 2 we're going to be doing that manually as well. So it's the values of the Pascal's triangle. And in the exams, they're pretty okay with you sort of like just working out Pascal's triangle manually, but imagine it was like the 15th row or something like that. That would be pretty awful. So that's when like this strategy might be a bit nicer to use. So, no. Oh yeah, so you'll notice that kind of like when I start to do my working out, I'll sort of, sometimes I'll write it like this, but sometimes I'll write it like that instead. So instead of 4C3, sometimes the textbook as well and the exams will instead write it as 4/3. So I'll just show you an example of what that means. So, e.g., 4C3 could be instead written as this bracket 4/3. And you see that that seems to be the most popular way I see it written. Like maybe the instruction will be work this out, and then you automatically just have to realise that it means work out 4C3. But this way can be represented as well, and this way can be shown too. I tend to find our textbook tends to do it this way mainly, and this way sometimes as well. I don't really see it done like that too much in our textbook, but in some other textbooks they write it like that. So I thought we'd leave it in there. Yeah, so we said they can be found from Pascal's triangle or by just doing it manually on the calculator like this. Now we get to try some hard ones. So now use Pascal's triangle or your GDC if you want to just practice doing that NCR stuff instead to complete the following expansions. So before the expansions were easy because we just had A and B. Now it's just a little bit trickier because instead of A and B we're going to have this and this. So if it helps, write it out with A and B first, and then you could just sub in 1 and x in your final answer, and then just do the you know, if it's 2x squared you would have to change it to 4x squared. Or we could manually just do it from here. So if it was, I'll do the first one in terms of A and B to start with, just to show you what I meant by that. So if it happens to be a power of 5, how many terms will there be in the final answer? 6, yep. And so which row in Pascal's triangle has 6 numbers in it? The 5th one? And what are those numbers? We'll use Pascal's to start with. 1 obviously.
5, 10, 5, 1.
Yeah. So that's a way of avoiding picking the wrong row. I tend to think, okay, if it's the power of 5, there's got to be 6 terms from Pascal's triangle. 6 terms in my final answer. So sometimes by accident people might pick the row above it or below it by mistake. So that's a way of double checking, have I picked the right row from Pascal's triangle. If this was A and B, that would be easy. It would be just simply, as you probably guessed, it would just be A to the power of 5. And then what would it be next? Plus 5. Descending powers of 8. Yep. B, yep, B to the 1, yep. Plus 10. Yep. It can be good to double check you're not by accident going down and then up again in powers of A or something like that. Yep, you keep going down, good. Yep. And then plus 1, trying to fit all on one bit. B5. So if it was 1 and negative x instead, you could think of that as 1 plus negative x if that helps. 1 and negative x instead. We can now into this just replace the a's with the number 1 and replace the b's with negative x. I'm going to do it painfully kind of by subbing them in manually to begin with. Don't forget you've got the coefficients in there as well. So a to the power of 5, of course, would just be 1 to the power of 5. You don't need brackets even for that one. That's easy enough. Plus 5. So a is 1. If you want, you can colour code it. It helps. B is negative x. So just be aware the sign's important. It's negative x that would be subbed in.
So when it's written like, so 1 minus x to the power of 5, so 1 is A and x is negative x.
Yeah, is B, yeah. You can think of it like this here, exactly. A equals 1, B equals negative x. That's correct, yeah. And then plus 10. I'm sort of doing and then negative x can be squared. sign's important because in this case it's going to make the whole, would you agree this makes the entire term negative in that one? Yep. But when you square this x, would you agree that it becomes positive overall? So that becomes a positive. So that's why the sign is important. It's going to affect what goes here in the middle. So continue on. In future you won't need to write it out as painfully as this, you'll probably just realise what the answers are. 10. Oops. That's pretty painful doing that. And then we could just write out what the final answer would be. So 1 to the power of 5 is 1, yeah. This is easy. When it's 1, it's no problem. When you've got numbers like 2, that's when it gets a bit trickier. Because you'd have to do 2 to the power of 4 and then times that by 5. Do you agree that overall this term is going to be negative? Yep. Negative 5, yeah. Nice one. What would this one become? Yep. Perfect, yeah. 10x squared, yeah. Would this one become positive or negative overall? Negative, yeah. You're right. So you have to pick up when it's in one power. You get the same? Notice that it's kind of alternating, isn't it? A negative, positive, negative, positive, negative. Due to the fact that when you raise a negative to an odd power, you get a negative. When you raise a negative to a positive power, you get a positive. So eventually, like, I'm just doing it painfully and long the first time, but eventually you probably get faster and you might not need to write it out like that. But just to begin with, because we're just getting the concept to begin with now, we can write it out painfully long like that. They are quite often, and quite often questions are just in exams. This could be asked in an exam where you're asked to write out an expansion about that long, but sometimes I might say the expansions to the power of 10, but they just want you to find a single term. That's very common in exams because they don't want to have to mark an entire big process. They just want to mark getting that term only or getting that term only. So then we do the same for this one. So power of 4, how many terms will there be in the final answer? 5, yep. So which row in Pascal's triangle has got 5 numbers in it? Yeah, it's 1, 4, 6, 4, 1, isn't it? Main thing is make sure you've got these numbers right to begin with. That would be a shame. So using 1, 4, 6, 6, 4, 1. You don't have to write it out with all the A's and B's if you don't want to. You're welcome to try to go straight to this if you like. If that helps though, do that and then change it into that one. So in the next one, if you want to, you don't have to write out all the A's and B's versions unless you feel it helps. Again, this is a nice one because we have the number 1. It's an easy one to calculate. Squared. another way you could check it is overall the exponent should add up to 4. Like 3 plus 1 adds up to 4, 2 plus 2 adds up to 4, 1 plus 3 adds up to 4, that adds up to 4. Rewrite that one later. You probably know that one. So what's 4 times 1 cubed times 2x? It's easy because all of these are going to be pluses. 8x, yeah. It's worth having a little think about it. Just a think. You might want to, this is easy, but what's 2x squared? Or 2x? 4x squared. Yeah, that's important. Some people might by accident think that's 2x squared, but 2x times 2x is 4x squared. So even maybe say it in your head, 2x times 2x. That's the most common error I see is people by accident call this 2x squared. It's not, it's 4x squared. 2x times 2x times 2x, what would that be?
8 squared.
Close. 8x to the power of? Very good. 8x cubed times 4, 32, x cubed. Also check, like you can see, powers of x are going up, that's good. And then 2x times 2x times 2x times 2x. I'll show you a common error. That's a common bit of what mistake has been made there.
It's 16x.
Yeah, it should be 16. The person just did 2 times 4. Right, it should be 2 to the power of 4. 16x4. Then have a look at it, have a look and think, power of 4, have I got 5 terms? Yes, I have. In this case, yeah, powers of x were going up, that's good. So little things that you can look at afterwards. And another one which we'll do painfully and long like this one. But it's only to the power of 3, which is nice. And it's got a negative in it as well. So you notice we'll have alternating positive and negative answers. So power of 3 means there's going to be how many terms in the expansion? 4. 4, yep. So what row of Pascal's triangle, what numbers?
1, 3, 2, 1.
Yeah, good, yeah. You're going to become really good at knowing the numbers in Pascal's triangle. One, and then do all this again. So the first one is, so it's 1, which is making it easy again. 1 to the power of 3. It's going to be the power of that number. And what's the coefficient? 1 powers of 1 goes down, powers of 3x are going up. Oh, sorry, powers of negative 3x, I should have said. It's negative 3x. It helps write in the 1, if that helps keep on track. 3. 1. So I've got 1, 2, 3, last one is just 1, so that's negative 3x to the power of 3. That's 1 cubed, you've probably got 1. What will this term become overall? What will be the second term? Yeah, it's negative 9x. It's negative 3x times 3. What will be that term overall?
27x.
Yeah, good, yeah, positive. Because negative 3x all squared is positive 9x squared. And the last term? Yeah. So notice we had a 27 and a 27, but that's just because there was a 3 as a red coefficient on that second last term. and because that became 9, 9 times 3 made 27. So you might look at that and think, that's weird. But then you can see it makes sense because there was a 3 there. That's why we got a 27 here. Are there any questions about those ones so far? It really is like this long-winded. You'll be doing lots of this kind of stuff. We get really good at it. What's really common though is them just asking for a single term. So here they've been a bit nicer. They haven't asked for every single term in the expansions of these two. They've just asked for the x squared term, the x cubed term, and the x fourth term. So if you were struggling to think of that, you could do the entire expansion, no problem. And then just write out the x squared term is this. Like, for example, the x squared term is that. The x cubed term is that, and there would be an x fourth term because these are 6 and 7 as well. So if it helps, definitely feel free to do the entire expansion. You're welcome to sort of start to predict, okay, at what point will there be the x squared term in the mix? And just try to work out that term only. Do you want to have a go at trying that? Trying to do that rather than do the entire expansion? This, by the way, is lesson 3. So this investigation's good because it kind of, this is lesson 3 already. Kind of like when you get to lesson 3, this is it. And when you get to lesson 4, this is it. Where rather than being asked for the entire expansion, they just want you to find a single term. And you can kind of just not do the entire expansion, just work out that one. So it might be helpful still to know Pascal's triangle. So if it was the 6th power, how many terms would there be in the final expansion? 7, yeah. So what numbers from Pascal's triangle should we be using here? Yeah, and then you would check 1, 2, 3, 4, 5, 6, 7. Yep, so you know you've got the right one. And then you can try to think, remember that x is the second term. So which one of these will have the x squared term with it? Would this one have an x squared term, x term in there at all? No. What would be the exponent on this one? So the x to the power of 1. Because remember the second term, the exponents are going up by 1. So what would be the exponent on the x for this one? X squared, yep. And this one, x cubed, yeah. So if you want, you can kind of write out a little plan like that. That one's going to have an x, that's going to have an x squared. That one's going to have an x cubed. That one's going to have an x to the 4. That one's going to have an x to the 5. That one's going to have an x to the 6, if that helps. And that's because the second term is x. If the first term was x, then that's going to be x6, x5, x4, x3, x2, x1. But yeah, so that's why we've got ascending powers of x, because x is the second term. If it was x was the first term, it would be descending powers of x. So to be honest, maybe if you want to do that, we can make the second one the other way around. Just so you can practice doing that if you want. But, so you can practice just finding these ones. X squared term, what will that one be? What will this one be? And what will that one be? The 8. So you know that the x squared term is going to start have 15 as its coefficient. I'll do it in red. Just keep the pattern going. All the pattern going. 15. If that's x squared, what would be the exponent on the 1 out of interest? Because the exponents we need to add to 6. 4, yeah. So that's going to be 1 to the power of 4. Because it's easy enough when it's 1, to be honest. But imagine it wasn't 1, maybe it was 3 or something like 2. So you would have to put that in. Because x, and this one's x squared. So then x squared. Because those two exponents have to add up to 6. You can just work out that answer. So that's an easy one. What's it going to end up being? You just get 15x squared. You'll be right. The next one's going to have 20 at the front. What would be the exponent on the 1? That's cubed. 3. Yep. Oh my gosh, it is 2. Thank you. Yeah. So luckily that doesn't affect this one. Thank goodness, because negative x squared is going to become a positive. Negative x squared. Luckily that won't change that one. But this one, it definitely is going to affect it. It's going to be negative x cubed. Makes sense because the exponents add up to 6. So final answer, would it be a positive or a negative? Negative, yeah, because it's to an odd power. Negative 20 x cubed. 2 answers fine for this one. Let's look at third. 15. Positive or negative term overall? Positive, yeah, because it's to the even power. Pretty easy, especially when you've got the ones. It's such a good question when you can see when one of the terms is 1. So much easier. Have you done these ones already? Or should we just have some time? So it's fine if you haven't. I was just wondering if you're just sitting there bored, thinking, yes, we know the answer. Stop doing this. Let's do these ones then. So power of 7, so there's going to be 8 terms. So what Pascal's triangles numbers? And then we just have 8 terms there. So I've made it a bit boring. I made the 3x at the front. Do you want to try changing it to this? It's the same answer overall. Just to practice having the x at the front instead. Just something different. It's fine. And if you've started it already the other way around, you're going to get the same final answer. So it doesn't matter. Because 1 plus 3x is the same as 3x plus 1. So let's maybe change that question too. So then we can kind of see, instead of ascending powers of x, we can see what it's like when there's descending powers of x. So we agree that this one's going to end up with an x to the 7th term. There'll be a 3 there too, but like overall the power of x will be 7. X to the 6th, descending powers of x this time because a is in the a position. X, and then the last one is just 1 to the power of 7, so there's no x in the last. So that helps identify which terms we're trying to work out, and we want x squared this time, x cubed, and x4 again. Okay, just to keep it even, I'm going to work out x squared first. It doesn't matter if you want to have x4 first. Squared, 21, and I put the first one in brackets. 21, 3x is going to be squared, obviously, because it's x squared. So that means the other term has to be raised to the power of 5. Exponents need to add to 6. And I gave you a nice easy one because 1 is easy. 1 to the power of 1 is easy to work out. But we've got to factor in 3x times 3x is 9x squared, and then 21 times 9. So it's 21 times 9, 180 something.
189.
Yeah, 21 times 9.
189.
Yeah, 189, yeah. 189, and then obviously x squared. And it's handy, none of them will be negative because they're both a and b are positive. So we don't even need to think about that for this one. That x14, that x cubed term next. We can already see that it's x cubed, so that's going to be x cubed if you want. It tells us that the next term, 1, needs to be the power of 4, because overall it should give us the power of 7. So it's going to be the coefficient 27 times 35. It's okay to use calculator to do that one. 345? Yeah, that's good. Yep, 945. X cubed. And it's x to the 4, so you know it's 4 on the 3x. It's the exponent. So what's the exponent on the 1?
3.
Because we have to add to 7. 3 to the, what is 3 to the power of 4? That's a good thing to know in your head, by the way. 81, good. And 35 times 81.
2000.
X to the 4. So this is a more common kind of question, and in an exam, rather than do an entire expansion, sometimes they'll just want to know what is the third term or what is the x to the 4 term. Like rather, I don't really see them ask for all three, but like just a single term, because that's easy for them to mark, and it also proves that you at least understand the entire process. It's difficult for them to mark something like that. There's lots of things they have to look at. So this is a nice, favourable question for an examiner to have to mark. And this is lesson 4. So if you want to make a little note, this is kind of the basis of lesson 4, which is finding a single term in a binomial expansion. This one, these ones are just lesson 3. These are 3. So that's why I like this investigation card, because it kind of gives you an overview of the entire unit. And then we get to practice maybe some more difficult questions. Oh, any questions about any of that? It's pretty dry.
It's pretty straightforward.
Straightforward, good, yeah. It does take a lot of concentration, doesn't it, though?
Mm-hmm.
Like really keeping on track, and in your own brain you'll probably work out ways to double check you haven't made boo-boos. Like for me, I find it helpful. Okay, power of 4, I should have 5 terms in the final expansion. That's one thing I like to check. Are my powers ascending? Is the other one descending? And do my exponents add up to that? That's another thing I like to check. That's the common error I've made. Like I'll write squared and a cube here, but they should be adding up to 4. Can't think of any other little backup checks at this point. I need to hand out lesson 2 to you, don't I? Yeah. So there's no exercise in the textbook for this. This was just a little investigation that discovers the binomial theorem. Go to the next page. And gives you an overview of the entire unit. I want to go to the next page. Okay. Wherever. I can still hand this to you while it's confusing to me. So see just 2 pages front and back. This one's using this nice fancy formula, just practicing using those ones manually. So you're going to be doing a lot of factorial calculations. So it's a short unit, but it's one that people need a lot of focus on. So it's good. It's very good. It's abstract. There's lots of proof that you're right. After we've done notes and everything, just to practice, so you can identify strategies for avoiding errors. Maybe if I just pull it. Great, good. It's recording. Okay, great. Fair enough. Okay, here we go. Lesson 2. We'll just get through a bit of this. Finding the binomial coefficient using this gorgeous formula. So by the binomial coefficient, we're kind of meaning like the values in Pascal's triangle. Imagine it was the 20th row in Pascal's triangle. So you don't want to have to do that by doing Pascal's triangle. You could do it by doing this, which to be honest is a lot of work anyway. But there are questions nowadays in the exams, as I said in the new study outline for SL, that require you to formally use this formula. It used to be just something extra we taught as background, but now they have actual questions on it in the exams. So what is a factorial anyway? So in case anyone forgot, a factorial is where you multiply a number n by 1 less than n, and then 1 less than that value, and so on, that kind of thing. For example, let's evaluate the following. 3 factorial. So you would still write it all out. 3 times 2 times 1, which equals 4 factorial. 4 times 3 times 2 times 1. What's my funny x? Yeah, just go through and work them all out if you want. Oops. What did I miss? I missed something.
Yeah, take these to the exact same.
Yeah, did you?
I went from 4 to 2. Good job.
Yeah, so if ever you're working out a factorial, you might want to just go read over what you wrote, because the brain goes a bit funny. Basically, what's 6 times 120?
720.
720, cool. 720 done. So some of you before were already coming up with an idea to write an expression for the following. I think Felice mentioned something and Paige mentioned something to put at the end. What did you suggest, Felice? Yeah. So rather than use the multiply symbol, use your brackets. Yep. Yeah. You wouldn't have to write out that many, I just thought. So writing out just a few and then dot dot, like Paige said, the dot dot dot. Because we don't know how big n is, like maybe n was only 3, in which case it would have only gone to halfway across. But so just writing out n minus 1, n minus 2, dot 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 is pretty much enough. That might be helpful for certain questions, like maybe you're asked to come up with an expression and plug it into that weird formula at the top of the page. Now try to work out how you enter something like 9 factorial straight into your graphing calculator and write the answer to 9 factorial and the instructions. Like basically I want you to find the factorial button. So have a little experiment on your calculator. Let's see, do we have a confirmation? Just, oh, thanks again. So we can write the number. Yeah, it takes a while. Yep. So how did you do that, Olwen? Where did you go to? Math. Math, then prob. Oh, so you saw it before. Sneaky. And then did you scroll down to the 4th?
Yeah, you can just do alpha F2 and then press enter.
Okay, cool. So alpha F2 is another way. Let's see, alpha. Where's F2? Ah, thank you. Yep. I didn't know that. Thank you. That's faster. Oh, that's just found the factorial of the factorial. So would I have to press 9 first or 9 after? 9 after, okay. Alpha F2. So feel free to write both of those down. Number 9. And then put in the number 9.
Oh my goodness.
Oh, for me it came up with an
You
error.
have to put the 9. Okay.
Okay, you do put the 9 first. Okay, cool.
And then you just have to press the 9 button again.
Like the alpha thing. Oh, you can scroll down, yeah. Just for the purpose of the demo. So I'm not sure how Crystal will do it on her calculator, but hopefully the computer's gone a bit funny.
No, I meant like you're not gonna wake up.
Okay, good.
Scaring me. No,
And you end up with 362880.
You're not gonna wake up when you're gonna wake up when you're supposed to. Switch it out.
So Owen's way. So you just write the instructions you want. It seems the board's frozen on me. Oh, you would have to enter 9, and you have to enter 9 in first too, don't you? I forgot that. 9, then map scroll, and then that thing. And then all you could do the other way that's been discovered. Just type 9, and then it was alpha F2, which comes from window, button, and then you would select factorial, which is the 9th one. Enter, of course. You had to press enter, did you? Can't remember. So we can end just there if you like, because it's 9:42. There is an exercise associated with L2, but feel free, we can start it next lesson if you like. Now I can stop this.